All right, we're back. We're on page 6 of note 16 of Calc. Nope, we're on page 6 of note 17. We're on page 6 of 16 of note 17 of Calc C. We're talking about polar coordinates, and we're finally going to do some calculus with them. Everything before this has really just been a review of polar. You should definitely watch or go through note 16 of math analysis, which is really where you first learn like everything about polar. So let's talk about slope for polar. So the slope of a polar curve is still dy dx, right? That's the slope of the tangent line. It's the well, I was going to say rate of change, but like I'm not 100% sure what I would mean by that. So let's be really careful and just say the slope of the tangent line to a polar curve is still dy dx, even though there's no y or x, right? There's an r and there's a theta. So it's not dr d theta, it's dy dx. So we have to deal with that. So there's that derivative exists in this universe. There's also dr d theta because r is a function of theta. So dr d theta is going to tell you about the rate of change of r. Now r is really just telling you like where you are relative to the origin, like how far from the origin, how far from the pole are you. So dr d theta is going to tell us about that. Dy dx is going to tell us the slope of the tangent line. And then we're going to have to figure out how to find dy dx. Let's talk about dr d theta first. So what I'm going to do is I'm going to switch over to GeoGebra. Everything we're going to talk about is kind of summarized here. There's this interplay between the sign of r, is r positive or negative, and the sign of dr d theta, is it positive or negative, and what's happening to your polar curve. So as I switch over, think about the relationship between velocity and acceleration, because it's a really similar relationship. It's actually, I would say it's basically the same relationship. So let's see. So this GeoGebra, I set this up so you can kind of like see the things on the side, including like I didn't bother hiding these. Our polar curve is cosine of 3 theta, right? So I'm using t for theta because theta is a really annoying thing to type. Rose curve, 3 petals. We know that it's going to take 6 increments. It's going to take 0 to pi to trace out the whole thing. And then if you want to graph this by hand, you do the rectangular and so on and so forth. What we want to look at is r of theta versus dr d theta, right? The rate of change. So at theta equals 0, r is positive, it's positive 1, and r prime is 0. So that's actually like a critical point. We're either at a maximum or a minimum. You can see we're definitely at a maximum. That's the farthest you'll ever get from the origin. We run into some like an issue you'll see. So here, r is positive, dr d theta is negative, and the important thing is you're getting closer to the origin. Let me change the step size on t because right now it's enormous. Well, I don't know if it's enormous, but it's too big. 0.05, let's say. Okay, so now I'm going to step through here. All right, so there, r is positive, dr d theta is negative. You're getting closer to the origin. Now at this point, we have switched, right? We switched. Now r is negative, dr d theta is negative. We're getting farther from the origin, farther from the pole. Now something's going to happen here. R is negative, dr d theta is negative. R is negative, dr d theta is positive. We go from getting farther from the pole to getting closer to the pole. So when r and dr d theta have opposite signs, we're going to be getting closer to the pole. When r and dr d theta have the same sign, we're going to be getting farther from the pole. And, you know, at that point where it switches, you're at like a relative maximum, relative minimum. In some contexts, both of those can mean the same thing in this particular case. Like you can see, this is going to be, so r prime, dr d theta is going to go from positive to negative, and we're at a maximum. We're the farthest we're ever going to be. Now what's happening over here is r prime, okay, here we go, going forward, r prime changes from negative to positive. It's a minimum. Graph the rectangular version of r prime, and you will see r prime goes from, r prime is going from negative to positive. Graph the rectangular version of r, and you will see that it has a relative minimum there, but it's the farthest you ever are from the pole. This is never really a confusing issue when you're actually doing a problem, but like clearly there's something going on there. So this is just to show you if r and r prime have the same sign, you are getting farther from the pole. If r and r prime have opposite signs, you're getting closer to the pole. That's all that we're saying. It's exactly the same as velocity and acceleration, right? When velocity and acceleration have the same signs, speed is increasing. When velocity and acceleration have opposite signs, speed is decreasing. This is an idea that we've encountered before. It's just like maybe you hadn't thought about it in the context of polar, because why would you have? So let's go back to the notes, see what it says, and then we'll go from there. So gotta get back. Here we are. All right, so dr theta tells you about the curve, tells you the curve relative to the origin. Are you getting closer to the origin? Are you getting farther from the origin? But it really matters what the sign of r is. So you have to think about both of those together. So if same sign, so I'll highlight the same sign things. If you have the same sign, you're getting farther. Same sign here, farther. And then if you have opposite signs, you're getting closer. Opposite signs, you're going to be getting closer or approaching the origin. So that's just something to keep in mind, right? Now your polar curves live in the xy plane. We just are considering all the points a little differently, right? So you have x, you have y. I'm going to draw like just a random curve. I don't know, what am I going to draw? I'm going to draw, I'm going to go for, I had a bad plan, didn't work out. Okay, so we have this, it's in the xy plane. So if I put a point here, and I do this, that's my tangent line, the slope of this is still change in y over change in x. So the slope of this is still going to be dy dx. And the next thing we want to do is we want to work out what that is. So I think what I'll actually do is I'm going to actually cut this video in two and come back in the next one and work all that out, because it's, I don't know, it's not going to take forever, but it's going to take a little bit. So I'll see you in the next video when we get that done.